Hi everyone, and welcome to this video where we will show you how to create a body-centered cubic BCC unit cell with Z struts using Rhino Grasshopper. It involves a fully parameterized unit cell geometry to control its implementation into larger and more complex uniform periodic lattice structures. A BCCZ or body-centered cubic with Z struts unit cell is a modified body-centered cubic or BCC lattice structure that incorporates additional struts along the Z-axis to enhance its strength and stiffness, making it particularly well suited for applications such as additive manufacturing and lightweight design. Unlike a standard BCC cell, which has struts intersecting in one center, the BCCZ adds a central vertical strut. Here is a detailed step-by-step workflow for creating a body-centered cubic or BCC structure with Z struts in Grasshopper. First, we will need to run a Grasshopper 2 inside a Rhino system. Before we begin geometry parameterization, we will enable a bifocals component to display all component names in the Grasshopper canvas or working space. In the first step, we create the necessary points where we need to generate the 8 corner points and 1 central point of the cube. So for this purpose, we add a number slider. This will control the overall size of our unit cell. So we set a boundary values between 1 and 10. And also we set 5 units as default value for our unit cell. Next, we create a center box using center box command. And we connect our number slider with each direction of the cube, X, Y, and Z. So this command will preview our cube with this volley set size. This will be our major element which controls our overall dimensions of center box. And what is the most important here, that this command gives us a cube positioned in world origin or 0, coordinates. Next, we add the construct brep command and make a connection between these two components, center box and the construct brep. This command allows us a fully control over the major topological elements like faces, edges, and vertices. So now this component allows us vertices output, which holds the 8 corner points of the cube. Now, besides these corner points, we also need to find a middle point of the cube over component volume, where we want to make a connection between our center box and this new component volume, which allows us preview of our middle point of the cube. This middle point will be connected with each corner points of the cube. For that purpose, we will use a command line, command between 2 points, and we want to connect our centroid, middle point on the cube, with one input and vertices of the construct B rep with a second input. So if we make this preview disabled, and also if we make this preview disabled, we have our classic BCC unit cell where diagonal lines intersecting in the one middle point. So this is classic BCC unit cell, and now we must think about these corner points, which must be connected with the lower ones to make edges along the Z direction. For that purpose, we will use a new command, and it is box corners. And when we make connection between our new command box corners with the edges of the constructed B rep, because this output of the edges from our deconstruct B rep already contains all 12 outer edges of the cube. This single output includes the horizontal edges as well as the vertical Z struts we need for this kind of unit cell. So we make connection, and now we have active all corner points, but we must achieve connection between those in upper and those in lower part of the structure. For that purpose, we will use again a command line and make but line between 2 points and make connection between A output of the box corner with A input of the line and E output of the box corner with B input of the line. So in this moment we have two separated structures or two separated entities. One, as you can see when I click here, one structure is these diagonal lines intersecting in one middle point, and the second one is these vertical struts positioned in 4 sides of the cube. Now we must make integral part of these lines using new command, and that is join curves, and we want to make one integral or join curves using this output of the command line, those 4 vertical struts, and these diagonal lines also from the command line in the same input. Now when we mark our new command join curves, we have, as you can see, integral structure of our unit cell ready to add some kind of body and make it solid from it. For that purpose, we will use multi-pipe command and make connection between integrated or join curves with curves of multi-pipe. So in this moment we have our fully parameterized geometry and fully control over a newly created unit cell structure called BCCZ. And here you can see integral part of workflow, which allows us a fully controlled and fully parameterized geometry. In the end, we can create a baked model, solid baked model, ready for further implementation in the more complex workflows to create a periodic uniform structures. That's all for this session on parametric design, and stay tuned for the upcoming content on parametric modeling.